All right, number 12 on test 9. When students of mine saw test 9, they were excited because 4 questions in a row at the end of the test, you could use this method. So, for instance, it says for x is greater than or equal to 0. That's kind of just a snarky situation where if x had been like negative 1/2, this denominator would be equal to 0. So, look, I'm just going to start by saying I know why that's there. Like, that's literally just to make sure that we can't make the denominator undefined, because anything divided by 0 is undefined. I don't care about that. I'm trying x is 0, just to start with, because I know what their game is. So if x is 0, this whole thing is equal to 6. Well, answer choice A would be 5 over 1. Zeros for x's would just be 5 over 1. For B, it would be 6 over 1. For C, it would be 5 over 1. And for D, it would be 6 over 1. So all that game about x has to be greater than 0 is about is making the denominator defined. But just to be clear here, let's try a different number. Let's try x is 1. If x is 1, then we get 1 over 1/3, right? 2 plus 1 is 3, so that's 1/3 plus 5. So 5 plus 1/3. 5 and 1/3. That's what I'm looking for. Go to answer choice B. If you put x is 1 in, you're going to get 2 plus 6, which is 8. And 8 over 3 is definitely not 5/3 because 8/3 is less than 3, right? 9/3 is 3. We're looking for something bigger than that. It's answer choice D. And if you didn't believe me about the A and B thing, you could do the same thing here. Only D will work. 10 times 1 is 10 plus 6 is 16, and that's still over a 3. 16/3. Well, what's the deal with 16/3? Well, 16/3 is 15/3 and 1 extra third. So 5 is 15/3, 1 extra third. D is your right answer.